me start it, if you can let me know. Not only do we have numbers of people absent today, but Cole is going to be there too. So if you guys want to say hi to Cole, you can say hi to Cole. Hi, Cole. All right. So anyhow, adding radicals is just like adding like terms. So can we add 5x plus 3x? And the answer is yes. 5 of them plus 3 of them is 8 of them, 8x, right? That's the same concept as adding radicals. Exact same concept. So let's take a look at number 2. Only like radicals can be added, which are radicals with the same index and the same radicand. Only like radicals can be added, which are radicals with the same index and the same radicand. All right, so let me translate that for you. Same index. That means you can only add square roots with square roots. You can only add cube roots with cube roots. The index must match. But not only must the index match, everything under the radical sign has to match. That's the way you're going to add radicals. Thanks, John. So here's the rule. This is the SuperDuper rule. And again, it's a little harder with letters. So hold on. Before you do anything, let's do it with numbers in our heads. Don't put this in your notes. This would be so much easier if the A were a 10 and the B, don't do this in your notes, and the B were a 7, and let's make the C a 4. So 10 of them plus 7 of them is 17 of them. And 17 of them minus 4 of them is what? 13 of them. And what are the thems? The what ends? The square root of n, right? So if that were the problem, 10 times the square root of n plus 7 times the square root of n minus 4 times the square root of n, we'd end up with 13 times the square root of n. 13 of them. That's all it is with adding radicals. So how do you do it with letters? If you remember, we had to have a parentheses because we got to add the A amount, the coefficient, right? How many of the first one? There's a plus sign between the first and the second. The B is the second one. How many of them are there for the second one? And then we've got a minus sign for how many of them there are in the third one, right? And it's that many, and I'm going to take my blue, of them. And what is them? The square root of n, right? There's that many of them. It's just adding like terms. We can do that. You can do that. You can handle that. And that's all there is to it. All right, so let's do a couple examples. So look, in reality, this is 5 of them plus 2 of them. That's it. Now, maybe just one time I'll do it the rule way, but to be honest with you, the rule way is boring. Right? So 5 plus 2 of them, and say what the thems are? No, what are the thems? Square root of 2, right? Each them is different. You got to see what them are. That's great English. I love it. All right, so what do we have? 7 of them, right? 7 times the square root of 2. That's all we're doing. At least for the easy ones, all right? And I think they're all easy. Just there are a few that have some tricks associated with them. All right, so let's do it the easy way. Let's use a little bit of color. Let's use our red. So first off, we have how many of them? Say it. 7. And then how many? -15. And notice, right, I always include the sign, right? So 7 positives and 13 negatives leaves you 6 negatives, right? A -6. And what are they? -6 square root of 5s, right? We have a -6 times square root of 5. Just adding like terms. Look, if that was 7x minus 13x, what would you have? Negative 6x. Well, what are these? These are square roots of 5. So we're just figuring out how many we got left. We're adding. We're not multiplying. That was the last lesson, multiplying. And look, just like 2 times 3 doesn't equal 2 plus 3, you can't try to multiply the way you add, and you can't try to add the way you multiply. They're different. You got to keep them straight. Just keep it straight, and you'll be okay. All right, so I know it's impossible. Radicals are so confusing. I'm sure none of you can get it right, but try D. Go ahead and finish D. You can do the shortcut. You don't need to show the rule step. What do you end up with for D? I know it's impossible, but see what you get. Gabe's like, oh, boring. It's so easy. What do you think, Gabe? What do you got? How many agree with Gabe? All right, all you correct ones, right? Negative 12 of them and 3 more negatives of them, 15 negatives of them, right? We're just adding up how many there are. And they're like radicals because they have the same index. They're both square roots, and they have the same radicand. The radicands are 11. So then when you get to something like E, you're like, oh, no, it's impossible. I can't do E. Well, piece of cake, right? Go ahead and do E. Go ahead and do E. Go ahead and do E. Do E. All right, somebody raise their hand. Give me the answer to E. Adam, what do you got? How many agree with Adam? Negative 6 times the square root of 6. Let's see, a negative 2 of them and a positive 5 of them is a positive 3 of them. Positive 3 of them and a negative 9 of them is, yes, a negative 6 of them, right? These are easy. Easy. Okay. Let me get rid of my screen here so I can go higher. All right, so look at F. Look at F. So what are you going to do with F? Take a look at it. Think about what we learned. Jack, what do you think? Okay, and how do we do that? Should we make Jack a... Let's make Jack a Flores. Can we make Jack a Flores? Can we make Jack a tangent? Okay, we could adopt, but we don't want to go that far. So how are you going to make a 7 a 6? I mean, you know, can't go hocus pocus. Nothing up my left sleeve, nothing up my right, right? Can't do that. So what are we going to do, Gabe? What are we going to do?
Take the square root of 7.
How can we do that? Okay, we could square. Good thought. Okay, so Gabe's thinking ahead. Hey, we can get rid of square roots by squaring. But here's the big difference in that. Remember, we squared both sides of an equation, right? Is F an equation? See, but these are all the normal thoughts you should have as you're looking at your math. Hey, can I take this? Can I square both sides? That would allow me to be able to do something. But then you'd catch yourself and say, no, it's not an equation. I can't do that. Not an equation. That's how you get somewhere. You got to be thinking these thoughts. Josh? Okay, you want to multiply them. So that would kind of be like if I had 5 plus 7, that should equal 5 times 7. Does that sound good to you? All right, but you're thinking, and thinking leads to the right answer. Jordan? Okay, so you almost kind of want to distribute it. But where would that extra negative 5 times the square root of 7 come from? So you're like undistributing something that's not there. Here, you want to know the real quick, short answer? You know what the answer is? Are you ready? Give me a drum roll. Somebody give me a drum roll. That's the answer. That's the answer. Because you can't add them. They're not like radicals. You can't add them. You can't do anything with it. I can't do anything with it. Say, why did you put that? So that you guys will think about what you can add and what you can't add. Those can't be added. We can't do anything with them. It's just going to stay square root of 7 minus 5 times square root of 6. Now, we could use our calculator and get decimal round-offs. If we really, really had to know what it equals, we could get a decimal round-off. But again, in math, we really don't want round-offs. We want exact answers whenever possible, so we're just going to leave it. That's an exact answer. We really can't add them. They're not like radicals. They're both square roots. The index matches, but the radicand doesn't match. Can't add them. They don't add. Just like you can't add, what was it, 5 marbles and 3 Oreos? Can't add them. All right? They don't add. And those don't add. Okay. So now we're thinking of our like terms aspect. So then you can do G, right? Try G. You guys know how to do G. Do G. I'm going to use my color. Question, Jack, or answer? Hold on there. Is Quick Straw still on? Like cartoons have Quick Straw McGraw and Baba Louie? Anybody know who Quick Straw McGraw is and Baba Louie? You poor deprived people. Those were good cartoons. Like, you know, stuff like that. Bugs Bunny, the Road Runner. Oh, who's the mouse? The little Speedy Gonzales. That's so good. He's so good. Good cartoons. All right, so you look at this and you say, hey, I'm going to add the like terms up, the like radicals. I'm going to do the square roots of 6. A negative 2 of them and another negative 2 of them is a negative 4 of them. Do you agree? And now I'm going to do the square roots of 7. A positive 3 of those. And how many of this back one do I have? No, I don't have 0. I have a positive 1 of them, right? We don't show the ones, right? So 3 of them and 1 of them is 4 of them. Anybody get it right? All right, good numbers of you, right? We're just adding up the like stuff just like we added up like terms. Does that make sense? Hey, a negative 2 of the square roots of 6 and another negative 2 square roots of 6 is negative 4 square roots of 6. Positive 3 of the 7s and another positive 1 of the square roots of 7 is a positive 4. Adriana. Remember, 2 is the index, but 2 isn't how many of the square roots of 7 there are. So here's the analogy. If I just have the variable x, it's really 1x, but we don't bother to write the 1. And the exponent is really a 1 as well, but we don't bother to write that as well. We don't write any of that extra stuff because we just expect students to know it. So a square root of 7 is the same as a 1 times the square root of 7. Just like the cube root of 7 would be the same as a 1 times the cube root of 7. And let's say we had a 4th root of x squared, it's the same as 1 times the 4th root of x squared. We never show those 1s in front. And it's what gets students a lot of times because they don't think about that 1 being there. But it is. And the more you do it, the more use you get to it, and you don't have a problem with it. Okay? All right, let's do the next page. All right, so now we're going to try to goof you up a little because that other part was too easy, right? So now we got to throw some thinking into it. All right, so number 3. Simplify the radicals whenever possible. Simplify the radicals whenever possible. So watch. Here would be a normal thought process. Look at A. A student comes across problem A, and this is what they would think. First off, they would think, oh, I'm adding radicals. They need to be like radicals for me to add them. They're not like radicals, therefore, what's the answer? 3 times the square root of 2 minus 2 times the square root of 18. Does that make sense? That would be a normal thought process. However, this is the way it should actually go. Oh, I'm adding radicals. I need like radicals. I don't have like radicals. But can I simplify anything? And now we're back to the last lesson. What's the square root of 18? Isn't that a 2 times 9? You can do that. Go ahead and do that in your notes. Isn't that 18 at 2 times 9? Can we now simplify that square root of 18? Yeah. Can't we take the square root of 9? All right. So class, say it. What's the square root of 9? And where does the 3 go? Jack, where does it go? It comes out in front times the 2. Exactly, right? Anything you take the root of comes out in the front as a multiplier. So let's rewrite where we're at. We still have in the front that 3 times the square root of 2, right? So what should I write next? Somebody raise your hand and tell me, what would the next part be? Just go what's there. John? So finish it. So look at exactly what's here and tell me exactly what it becomes, that part. Somebody else? Jordan? Oh, come on, well, simplify that. Come on, you can do something there. Josh? Huh? No, not yet. We're not there yet. Caitlin? Just all we're doing is this part right now. What does that become? Right? Isn't that a negative 6 times the square root of 2, right? A negative 3 times a 2 is a negative 6, or a negative 2 times a 3 is a negative 6, isn't it? So really, guys, all I was after was doing that multiplication right there, right? We're simplifying that part. Okay, look where we're at right now. Can we now add these radicals? All of a sudden, they are like radicals, aren't they? So go ahead and finish that one off. Don't say it out loud. What do you get when you finish that off? Mr. Shockey, what do you think? So say it again. I couldn't hear you fully. Just like that. Good? How many agree? Uh-oh. Why is no one agreeing, Byron? Negative 3 times square root. How many agree now? All right, there you go. All right, good. Good. So that's good. You were able to recognize 3 positives, 6 negatives leaves us 3 negatives, right? We were able now to add them up because they were like terms. Okay. So what do we do with B here? Well, we're looking. So again, same process, right? Here's your thought process. Oh, I'm adding radicals. Are they like radicals? No. Can I simplify them? Yes. All right, go ahead and simplify. Okay, so here would be your thought process. Sam, what did you do with the square root of 75? Okay, and that's definitely a good way to go. Did you do anything with your 25? What'd you do with it? So what'd you put in front of the 3? And I agree, right? Square root of 25 is 5. So hopefully Sam now has 15 times the square root of 3 for the front. And hopefully you did as well. How many got 15 times square root of 3 for that front one? Okay, and if you didn't, do you agree that's what you should have gotten? Right? 5 times 3 is 15, and what's left inside square root of 3? All right, somebody tell me what you did on the back one. What'd you do on the back one? And again, I'm just trying to share the wealth and get people that haven't done anything yet. Eduardo, what are you going to do on the back? Ooh. You don't want to put anything in front until you figure out what you got. See, a 12 is a 4 times 3, isn't it? You agree with that? Don't want to skip that step. Because, Eduardo, what is the square root of 4? That's what goes out in front, right? Not a 4. So don't skip that step because you'll end up missing something you know what to do with, okay? You don't want to do that. So now the second one is a 2 times the square root of 3. So, Devin, where are we going to end up? Awesome. 15 of them and 2 more of them is 17 of them, right? We're just adding like terms. How many ended up getting that one right? All right, good, good. Just got to be able to simplify, right? Get them to things you can take the square root of. You guys look. Square root of 2, 4. Square root of 9, 3. Square root of 16, 4. Square root of 25, 5. Square root of 36, 6. Square root of 49, 7. Square root of 84, 6. You're just looking for stuff that you can take the square root of. Square root of 100, 10. Square root of 121, 11. Square root of 144, 12. Square root of 169, 13. So you're just taking stuff you know. Square root of 225, 15. Okay, grand finale. Uh-oh, we've got a couple things here. So look, here's the thought process now. Listen now, this is what should be going on in your brain. I've got to observe the order of operations because I have multiplying right here. And multiplying, I must use what property? Say it if you know it. I got to use the distributive property. So first off, I got to multiply this times this. All right, so I don't want to skip steps and get you confused. 2 times 3 is 6, right? The number's out front. Do you agree? Well, let's leave inside the 6 times the 2. Because you know what? Do you already see how we can simplify that radical? But I'm going to leave it that way for now so I don't confuse you. Let's do the second distribution. Positive 2 times negative 4 is a negative 8. Do you agree? Okay. And now we have the square root of 6 times 6. Yes? Okay. And now we still have then plus the 3 times the square root of 2. Is that okay with everybody? Question, Jack? Because I'm always looking to simplify. And you talking about the 6 times 6? Because I don't want to confuse anybody. So though you already might see that we can take the root of that, others may not, and I don't want to assume they do. Okay? Yeah, I would do it on that step right there. Okay, let's do the 6 times 2. We all know a 6 is a 2 times 3. Do you guys see the 2 times 2 underneath? What is the square root of 2 times 2? No, what's the square root of 2 times 2? It's a 2. So what is our front now? 12 times the square root of 3. Do you agree? I'm glad one of you does. Are you guys with me? You with me? Okay. What's the next middle thing going to be? What do you get when you have a negative 8 times the square root of 6 times 6? What's the square root of 6 times 6? 6, right? What's a negative 8 times 6? A negative 48. And then we still have plus 3 times the square root of 2. Can we do anything further?
No. Well, yeah.
What? You can't do anything. You have 12 of the square roots of 3, like 12 marbles. You have a negative 48, like negative $48. And you have plus 3 times the square root of 2, like 3 Oreos. And none of them add up. And that's it. Now, if the back one would have been 2 times the square root of 3, we could have added it up with the front one. And sometimes they'll add. Sometimes they won't. All right, pay attention here because I'm making a change. I'm getting rid of 21. I'm getting rid of 22. I'm getting rid of 27. And I'm getting rid of 36, all right? 1 through 4, 9 through 14, 17, 18, 28, 43, 44. Keep up, keep up, keep up. Keep your notes with you when you go to do your homework. Have your notes with you. It'll help you out to figure out what's going on.